Here we go, last video. Of course, I had the wrong paper and I started to tape it, and now all of a sudden, now I got the right paper. Okay. This is it. Make no mistake where you are. This is it. You're going no further. This is it. Your homework. Ask your parents who sings that song. It's from the 80s. This is it. Make no mistake where you are. This is it. You're going no farther. Awesome 80s song. Ask your parents who sings it. In fact, you all can sing along. Here we go. We need the pH of a 0.003 molar solution of hydrochloric acid. So again, to find that, you take pH equals the negative log, the concentration of hydrogen ions. Now, eventually you'll see hydronium when you go to the Haskell. The Haskell, right, Mr. Rigner? The Haskell, that's how you say it, the Haskell. Anyway, at the Haskell, they'll teach you the hydronium ion. Here, we'll stick with this. Plug it in. 0.003. We should get a pH of approximately 2.52. Very simple, pretty strong acid. Okay? Now, that's 0.003 molar. Take a look at the next one. Let's see 0.03 molar. What do you notice? The concentration is increasing of the hydrogen ion. And again, we talked about this. What determines a weak or strong acid or a weak or strong base? Weak or strong is determined by how many ions can form. Does it ionize in solution? Does it form hydroxide or hydrogen ions? If it does it easily, when you dissolve it, strong base, strong acid. That's important. Concentration is how much you have. Okay? So a weak or strong acid is ability to ionize. Does it form ions easy in solution? That's very important. Okay. So now we're at the pH of 0.03. There's my phone, I'm not answering it. pH equals negative log 0.03 molar. Negative log of 0.03 molar, the pH is going to lower and become 1.52. pH is going to be 1.52. So the pH went down because we have a stronger solution of hydrochloric acid, more dissolved hydrogen ions. Okay, go down to number 4. Go down to number 4. Let's find the pH of sodium hydroxide. Okay, sodium hydroxide. We're worried about the hydroxide ion concentration. Look up top here. We're going to do this POH. And they'll show you a slightly different way in the high school with higher level math, which actually I think makes it easier. But we'll do it the long way at this stage. So POH equals negative log concentration of hydroxide ions, because that's what we're looking at. Hydroxide ion concentration. Okay? So to find that, type in negative log, and we have what, 0.005? And our answer is going to be 2.3 is our POH. But wait a second, that's an acid. No, to find the pH, we take the POH minus 2.3, which is the pH equals 14, sorry, brain fart, 14 minus the POH, okay? pH equals 14 minus 2.3. pH is going to give us approximately 11.7 is the pH, okay? So again, same calculation. Subtract from 14 to get the answer. Okay, so that's the pH of that. Okay? And if I found if you look at the next one, say do the next one, pH of a 0.05 molar solution of sodium hydroxide, this value will decrease, meaning this value will go up. Okay, so you do that problem. And I'll do one more because I have very limited time. I gotta go home. Last one, I'll do one, a longer one. Okay, this is as hard as it gets if you call this hard. You've got 28 grams of NaOH in 3 liters of solution. Okay, what's the pH? Okay, first off, it's NaOH. So you got to find the molarity first. Or excuse me, find the amount of moles first. You're given grams. 28 grams times the 1 mole over the molar mass, which is going to be 39.9 grams. Get a calculator? Need a calculator? 28 divided by 39.9. 0.7 moles of NaOH. That just gets me moles. Now I got to find molarity. So now I've got to do 0.7 moles of NaOH in 3 liters of solution. So I take 0.7 divided by 3 liters. I now have, right, a molarity of 0.23 molar. So far, that's not my pH. So now I've got 0.23 molar NaOH. What's the pH going to be? Okay, well I've got OH, so I got to take POH equals negative log concentration of hydroxide ions. Okay, I think we're running out of room up here. Let's bring it. Oh, I'm sure it's fine. POH equals negative log of 0.23. Negative log of 0.23, 0.64 is 0.64. Okay, so now we're at 0.64. But that's a low P. We don't want that. We got to subtract from 14. So in order to do that, we bring this back over here. We'll erase this now. To get the pH, we take 14 minus the POH. So to get the pH, we take 14 minus whatever answer I just got. Was it 0.63? Because of course I erased it. 0.63 pH of this base, is going to be really strong, is 13.4. Okay? Couple other things. Again, weak and strong acids and bases depend upon their ability to ionize in solution, form ions. Hydrogen ions, which eventually when you get to high school, the hydrogen ions will bond with H2O to form hydronium H3O. But the ability to ionize in solution is key. Now, keep in mind the properties. What do we know about solutions? They can conduct electricity if they're ionic solutions. So the stronger the acid or the stronger the base, think about it. Will it be a good conductor or not? So let's think, if I had a strong acid and a weak acid, would both of them conduct electricity? And if so, which one would conduct better? Think about what makes something strong. Ionization. Ooh, the I word, ionization. Dissolving. So would you want something, a strong acid or a strong base that dissolves pretty quickly? Or a weak acid or weak base that doesn't really dissolve at all? Or it takes a lot to dissolve? Okay, think about it. The answer is strong acids, strong bases that dissolve a lot are better conductors of heat and electricity. Okay? Something to think about. All right, very good. That's it. I'm done for the year. I'm tired. Hi, Miss Camilleri.
Hey, how are ya?
Good. I'm ready to go home. I need to relax. We're done. Very good. All right. Thank you very much for watching. Hopefully that helped. Bye. Have a good summer.